Okay, so today we are going to do the last little bit of lesson six, which is significant figures and measurement. And that's kind of this is kind of the entire point and or purpose of when we talk about significant figures, because when we talk about significant figures, we're really talking about measurements. So we've already learned how to identify um, how many significant figures a number has, and we've also learned how to add, subtract, multiply, and divide with them, but now we're going to learn how to measure and actually obtain them. So we know that sig figs in a measurement are all the digits that we know with 100% certainty plus one final digit that's estimated and it's somewhat uncertain. And I'm going to try to illustrate that now in a moment here. The other thing is that your measurement is only as accurate as your least accurate piece of equipment. So it can only be as accurate as the piece of equipment that is the least accurate. And as we do our first lab, that might become a little bit more apparent or obvious. So you have this diagram in your note sheet, and I want to take a little bit of time to talk about how we measure things in science. So here I have a picture of a pen, and it's lined up with a ruler, and the ruler is in centimeters. So at this point, I can tell by simply looking at it that this pen is bigger than 4 centimeters, but it's not as big as 5 centimeters. So I know it's bigger than 4 and it's not 5. So it's got to be 4 point something. So then if we go to this bump out right here, where it's zoomed in, each of these lines, so it's 4 centimeters here and 5 centimeters here, and then there's kind of a little longer line in the middle there, and that tells me that that's probably about halfway. So if this is 4 and this is this line right here, I'm going to say it's like 4. This would be 4.5. So now if that's 4.5 and I look at these other marks, these would be like 4.1, 4.2, 4.3, 4.4, so on and so forth. So what that tells me is each of these little hash lines here is worth zero point 0.1 of a centimeter. And so at that point, I can now zoom in and look at the tip of the pen, and I see that it is bigger than 4.7, but it's not as big as 4.8. So it's bigger than 4.7, but smaller than 4.8. So I know for sure that this particular pen is at least 4.7 centimeters. Now comes the estimation part. And so in this case, I'm going to estimate that it's somewhere between zero point 0.7 and zero point 0.8. And I'm going to say it's like 4.72. So my final answer here is going to be 4.7. And then I'm going to have this those are numbers that I know for sure. And then I'm going to have this estimated digit, which is a 2. And then we go back to the unit, which is centimeters, because we always want to have units on our numbers. So 4.72 centimeters. So again, usually when I record measures of significant figures, I do it in such a way that I usually underline the number that is an estimated digit. So that's with a ruler. And now we're going to take a look at these graduated cylinder pictures here. So first of all, the thing that I want to point out about measuring things in a graduated cylinder is something called the meniscus. So we call it the meniscus. Now the meniscus is the level of water that has a little bit of a curve in it. So it's essentially the level of the fluid in the container, in this case, the graduated cylinder, um, that has a dip in it. And that's really the least technical term I can come up with it. And so if we look at these graduated cylinders right here, this part of the line, or maybe this part of the line, or maybe even this part of the line, that's where the meniscus is. It's the top, it's the level of the fluid, but there's just this indentation or dip in it. And so we always measure fluids at the bottom of the meniscus. So in the case of the first one here, I am going to be measuring from where this line is right there. That's not my best work. Let's see if I can make that a little bit better. That's right where I'm going to be measuring. So I'm not going to be measuring up here, and I'm not going to be measuring up here. I'm going to be measuring right where that dip is at the lowest point. So we have to first of all figure out our scale. So I see that this cylinder is marked 50, 60, and then there's a bigger line dash right here, which looks like it's about halfway in between 50 and 60. So I'm going to guess that that's probably 55. Okay. And to be fair, it is 55. So that means that each one of these marks right here has to be worth like 1. So this is like 51, 52, 53, 54, and then 55. So this in this graduated cylinder, the each mark or incrementation is 1 milliliter. So now I'm going to read from the bottom of the meniscus. So I see that it's bigger than 55. It looks like it's right on 56, but it's definitely less than 57. So I'm going to say it looks like it's right on 56. So I'm going to give it 56. And now I have to estimate. So I'm going to give it a 0, 56.0. And that would be milliliters because it's a fluid. So even if it's right on the line, we still have to estimate that it's at a 0. So that's our estimation there. This next one is a little bit different. Here we have a graduated cylinder that has a marking of 3 and a marking of 4, and then there is a bigger, heavier dash that looks like it's right in the middle. So I'm going to estimate that that's probably 4.5, or not estimate. I'm going to guess that's probably 4.5, and I'm most likely right, but I'm going to check. So this would be 3.1, 3.2, 3.3, 3.4, and I misspoke when I said 4.5. It should really be 3.5, but the idea is still the same. So yeah, so each of these lines on this particular graduated cylinder is marked 0.1 milliliters. So going back to my measurement, again, I'm going to measure at the bottom of the meniscus here. And when I measure at the bottom of the meniscus, I see that it is bigger than 4.1, bigger than 4.2, bigger than 4.3, but not 4.4. So I'm going to say that it's at least 4.3. And then I see that the line itself is somewhere in between 4.3 and 4.4. And it looks like it's kind of in the middle. So I'm going to say 4.35, underline it, go back, and I'm going to give it the milliliters value because that's the fluid that we're working with. And then that was that one. So we have one more on this page. And the one more on this page, it looks like are marked at 20 and 30. And then there's one in the middle. I'm going to guess that that's probably 35. So because that one in the middle is a whole number, it tells me that each of these marks is probably a whole number. So 21, 20, 21, 22, 23, 24, 25. Yep, 25, not 35. Sorry, I'm getting ahead of myself. So, yep, it's definitely a 25er. So each one of these marks is 1 milliliter again. So now this one is 21, bigger than 21, bigger than 22, bigger than 23, but not quite 24. So I'm going to say it's like 23 point, and it looks like it's right. It's a little bit above being in the middle. So I'm going to say, I don't know, 23.7 maybe. And we're going to call that milliliters, and then everybody is happy. Okay. So my slide deck has a different set right here, but your notes packet doesn't have it, so we're going to skip that for now. And then we're going to come back to the ones that you have here in your note packet. And what I would like you to do is I would like you to pause the video, and I would like you to read these 3 graduated cylinders. They're labeled G, H, and I. And I hopefully and record your answer with one estimated digit and underline that digit, and then we'll come back and check. So go ahead and read those graduated cylinders and write down your volumes. All right, so I got 41.0 for the one on the left. I got 4.25 milliliters for the one in the middle, and I got 47.0 for the one on the right. The graduated cylinder on the left goes by 1 milliliters. The graduated cylinder in the middle goes by 0.1 milliliters, and the graduated cylinder on the right goes by 1 milliliter. So this is going to be the way that we talk about measuring in this class. We're always going to measure what we know for certain and then one extra digit. And so I'm going to stop the video here, and I'm going to then start the video again when we talk about accuracy and precision and percent error. And that would be the end of this lesson. So if you have any questions, make sure that you touch base with me before class. Otherwise, we'll talk in a bit.